Hey everybody, today we're going to be finding the derivative of the sixth tetration of x. We already found the derivative of the fifth tetration, which is this whole thing. And today we're going to be finding the derivative of the sixth tetration. Basically, so this is going to be one of the last few videos, if not the last video on this series, because it's getting kind of excessive. And so yeah, we're gonna be doing only a couple more of these, so I hope you're okay with that, because this is a lot and it's really hard to fit this whole thing on the board. So we're gonna have to stop at some point, and so this might be the last video. Maybe the next video will be the last one. I'm not quite sure exactly. So yeah. Basically, recall that this is the fifth tetration derivative, and so we're going to be using that, and we're just going to be using the method that we always use. So let's start. So we can set y. This y is equal to our sixth tetration. So let me give myself some more vertical space here. Y is equal to, and I'm just going to do x to the x to the x, x to the x to the x. So that is 6. And we're going to take the natural log. It doesn't really, actually, yeah, the log does move. The log does kind of matter, because we want to make it easy to take the derivative. Alright, so this is our little, natural log thing. And so then basically we can just say that ln y is equal to 5 of these times ln x. So 1, 2, 3, 4, 5 times ln x. It's going to put a little multiplication symbol there. And now we just take the natural log on both sides. This is going to give us y prime over y, and that's going to be equal to, well, this is, we're actually almost done with in terms of steps, but basically this is going to be equal to this times the natural log of that, so, the derivative of that, so we have x to the x to the x to the x to the x, 5 of them, times the derivative of ln x, which is 1 over x, so we can just subtract a 1 off here, so we just put the minus 1 there, plus the, again, this is just the product rule, so then we have ln x times the derivative of this, which I'm not going to write out right now. I'm going to leave that to write out in this space. So this is going to be times, I'm going to say the derivative of our fifth tetration of x. Alright, so I hope, by the way, I received comments saying my writing was a little small, so hopefully I'm making it a little bigger now. Let me just make this, I just want to make sure everybody can see it. So yeah, some of these, like with the x ones, I have to make this smaller because, I have no option. I'm going to run out of space. Okay, so now the part that actually matters. We are going to, multiply y on both sides to isolate our y prime. So, yeah, and then we're actually going to expand this using that. So that's where the bulk of this comes from. Like, this is not really that much of a formula, but this is just this whole thing. So, let's actually just do that. Okay, I just cut a little bit because I wasn't really happy with how I was doing, but here, let's just continue. So the derivative of the sixth tetration of x, and I'm going to have to use like all this space, right? And I'll just box it at the end, so it's okay. This is going to be equal to, so let's first multiply y. I'm not going to distribute because it's just too much, but so y is just our sixth tetration, so this is 1, 2, 3, 4, 5, 6, multiplied by just this, so x to 3, 4, 5, 3, 4, 5, minus 1 plus ln x multiplied by this whole thing. Okay, so this should be right. Yeah, this is a crazy expression. So yeah, let me just box it in. I'm gonna use the red. I'm not sure if the red's. Yeah, no, we're good. We're good with the red. All right, so that is our derivative. I think actually, yeah, this is going to be the last one. There's no way I can continue doing this. If the formula takes up this whole area, two rows of this, there's no way I can continue with that. So I'm sorry, but this is it. This is the last video. Are you happy with this? I hope that this I hope that this is actually correct, because if it's not, if I messed up like on the second derivative some way down the road, that would suck. But you know, this is what I have. This is the sixth derivative of the sixth iteration of x. So yeah, that's pretty much it. Hopefully you enjoyed, and yeah, I'll see you in the next episode. Well, not of this series, but in some other series. Bye.